Hey everyone, it's Nick here. So in this video, I'm going to show you how to write a full stack search implementation. Search is something that's very common for a Flutter application, and usually you're searching against a large volume of data. Typically, it's not a good idea to cache that on the device. You're searching against some kind of backend API. It could be a traditional database that you have the data you're searching against in, or it could be in something that is geared towards search, such as Elasticsearch, this actual search index, or a service like Algolia. So in this video, we're going to walk through step-by-step how to implement an attractive search experience for users. As they type, it will search. I'm going to give a little intro to database design and how to implement this easily with Supabase, which is a so-called platform as a service. It's kind of like Firebase in a way. So if I was writing this myself for a small or medium-sized app, I actually would not write custom backend code. I would do what we're going to do in this video, which is set up some database schema, populate it with some data, and it's going to give us automatically an API, and we're going to search against the database that way. Also, if you're new here, my name is Nick. I've been teaching Flutter for 4 years and counting now, and a software engineer for 20 years. I've worked on many different types of application sizes for mobile experiences. So this is the app that we're going to build, and what we're going to do, first of all, on the front end is implement a screen with a nav bar at the top, which is with a title here. This is using a custom font, and below it is a text field where you can type in a name of someone. It could be anyone. And I have generated 100,000 names. And as we type, it will search a actual backend, and it will come up with the search results, and we can scroll through these pretty smoothly, and there are automatically generated gradients, color gradients for each one. That's the app, and let's get started. All right, so let's get started. We have the full source code in the show notes below. As you can see here, this is the link to it. The required skill level for this is intermediate. That means very roughly, if you have some basic Flutter experience and you can code on a basic level, you should be fine. That's what I mean about intermediate. Things we're going to cover in this tutorial in terms of skills learned, we're going to cover Flutter search using a TextFormField and the search results as a grid view. So each search result is going to be a tile in that grid view we're going to render. We're going to render randomized color gradients. That's pretty fun. We're going to cover Flutter theming, and especially with Google Fonts package, how to use themes for your headers, your text, all kinds of different styles, and how do you easily use a custom font. We're going to generate a high volume of users as a CSV file and learn how to import it into a database, a Postgres database specifically. I'm going to touch on some SQL Schema Basics. We're going to cover Postgres full text search concepts and features. So Postgres is the type of database that's extremely popular that is used by Supabase, and it's going to be pretty simple, as you'll see, to set up a full search index so we can perform searches very fast. We're also going to use Supabase itself to set up the actual database and import our data. We're going to use the Flutter Supabase package to wire up our screen to our backend, and Supabase offers a nice, cool package for doing that quite easily. So I'm going to cover the implementation steps so you have a general idea of how to do this, right? We're going to create a Flutter project. We're going to implement a simple search screen. We're going to hard code like just some sample data. On the back end, I've generated a CSV file. We're going to import that. I'm going to create a Supabase project for you, and we're going to create the actual schema. And we're going to also use a SQL client to import that data and look at the data as well. Because if you're working with a database, you're probably going to need a client for that. So we'll touch on that. And we're going to try out some test queries. So that's the backend. And finally, we're going to integrate it all. So we're going to integrate Flutter Supabase. We're going to wire up the text fields on changed handler to update the search results, and I'm going to just demo the finalized result. Okay, so let's get started here on creating our project, our screen, our routes, And I will hide this and show a terminal now. What I like to do is have a separate terminal open, but some people like to use it in like Visual Studio Code. There's a terminal. I'm sure there's one in Android Studio, what have you. But what I'm going to do is do Flutter upgrade first, and I want to make sure I'm using the latest version of Flutter, so I am. And I'm going to say Flutter create, and my project is called Super Search, so I'm going to call it that. We use an underscore in the Dart world for like directory names and file names, so I'm going to create that. All right, now that we created our project, I'm going to go cd Super Search, and I'm going to open my favorite IDE. I'm using Visual Studio Code, but Android Studio or other IDEs are fine. This is a fresh Flutter project. I'm going to increase the text size so you can see it okay. And Visual Studio Code is going to crunch away here to load up the project. Okay, so we have our main.dart. We're going to go to main.dart and remove all of this code. This is not how we want to start any kind of realistic sample, real project, what have you. It's a bit just confusing. What I typically do when I start a project, I have a main.dart and I have an app.dart. So I'm going to create an app.dart file in the lib directory. And in my main.dart, I'm just going to have a very simple implementation here. And what it's going to do is it's going to import a file called app.dart, and it's going to use the material design package. And it's just going to say run app. And I have a const here because we're only going to have one instance of the app that's not going to change. So this is going to optimize the kind of runtime a little bit by using const. And I create an app here. So I haven't created that, so there's an error. I'm going to go into app.dart. And what I want to do is render a basically a very simple material app widget here. So ignore the errors at the top. I have a material app here. I have a title. And what this is going to allow us to do, this material app, is going to give us a scaffolding for other screens in the app that need like a navigation bar or other elements. So the basics it needs is a title, what your home page is, the first page that appears. In our case, there's an error because we haven't implemented this page. It's called search. It's going to be called search in a moment. And there's a theme. So an app theme is something we'll touch on in a moment, but you can ignore that for now. And now we're going to create a style and search. So style.dart is going to be a separate file in the lib directory where we keep all the basic style and theme and all that stuff. And right now, it's going to be very, very, very simple. We're going to instantiate a very totally blank theme data instance called app theme. And because we're instantiating this and assigning it to this final member here, app theme, we can then use it in our app.dart because we imported it. And now I can uncomment this theme here because I have it already. It's not going to error out. So I have theme as app theme. So as you'll see later, when we theme things, when we want to apply style, because we're using this theme for our material app, it will apply that theme pretty easily with like low tech debt or boilerplate code. It'll be very clean. And you'll see that. Next, we are going to implement the search screen. So what I like to do when I set up a project is I have a very, very basic skeleton of my app. So for the main screens in my app, I'm having a blank page that doesn't do anything, but at least I'm setting up all the routing. And if I run the app, it'll show a blank screen. And I know the app will just work at a basic level, even though it's not functional. So I'm setting up all the foundational pages here. Now, in terms of how I like to organize code, I usually have one directory called screens, and it's very clear that there are screens in this directory. And in each directory here, for each name of my screen, I'm going to create one folder. So the first screen and the only screen we have here is called search. So I'm going to have a directory here called search. And in there, I have a file, and it's going to be called the same name as the directory. So this kind of denotes to the person reading the code that in the search directory, the search.dart file is the main file that is going to be used for rendering my screen. So let's continue here. Let's implement a very, very basic stateful widget. And the reason why this is stateful, because our UI has to react to what we are changing if data changes. And the data that's going to change, you'll see, is some search results and something that whatever the user types. So first, I'm going to create that very simple stateful widget. And this shouldn't be like alien to you. If it is, I would pause this video and read up or look at some of my videos on basic stateful widgets. So we have a search widget here and search state. We're going to fill this out. And all it is it has, because we're using material app, we can use this cool scaffold widget, which gives us an app bar at the top. It's basically a navigation bar with a title called search users in there, and a body right below. And right now I use a blank container widget to kind of have absolutely nothing there. So next, just now that there are no errors, I'm gonna delete this test directory because I will make a video on integration tests and all that stuff, but I don't usually like to have code out there that's not used, especially code that has an error in it. Even though I can run the project, I typically like to remove it. So what I'm gonna do is I'm gonna start my simulator. When I already have it started here, going to put it to the right here and resize it. And then I'm just going to run my app. So I'm going to save app.dart, make sure this is all working. I'm going to go to, in Visual Studio Code in the menu, I'm going to go to run and then start debugging. So one trick I like to do if I'm using the iOS simulator, and the Android emulator also has this feature, is I go to Window in the menu here and I say stay on top. That way the simulator and emulator will stay on top no matter what. And the Android emulator has roughly the same features as well. So let's continue. Right next, we're going to add a grid view with some hard-coded data, right? And hard-coded data means probably just 3 sample search results, right? So we want to be able, the reason why we're doing this is that we want to make sure the UI generally looks okay before we get working on our backend. Some people want to work on the backend first and then the front end second, but it really doesn't matter too much. My recommendation is to at least have some kind of basic functionality in the front end and something very basic that works in the back end. And then you should, as long as it works generally, you should be good and you can iterate on those features together, right? And hopefully you'll create tests and integration tests that will make sure those are still working as you add features in your app. So we want to, we have users, right? We have the concept of a user, and let's talk about data modeling for a sec, because data modeling is really important to think about when you're implementing an app, right? So the data modeling means that what are the nouns or the things in our app that we have to think about in terms of data, right? In this app, it's very simple. There's one model, which is called a user. And in our case, since it's a very simple app, we're not going to create any kind of physical model like a Dart file to represent a user. We're just going to have a list of strings, and each item is going to be a name of someone. That's it. But it's good to at least think of what that data is going to look like. So in memory, we're going to persist that to, as you'll see in a moment, a list of strings. So now let's add some like hard-coded data. So in my search state field here, class rather, I'm going to add one member first. It's going to be a list of strings, and these represent our search results. When we actually wire this up to the backend, we're going to remove this hard-coded data, and we'll just left with the results here. Now, the reason why do we have a question mark here? That's Dart's like null safety feature. That means that this value can be nullable. And the reason why we want this nullable is because when we show the search results, there's going to be 3 states. One state is a blank slate where we start the app and we don't show anything in the search results. That means the results are null, and we want to render it that way on the screen. The second state is when it has search results, so it won't be null and the list is going to be populated. The third state is when there are no search results found from the backend. The backend couldn't find anything based on what we searched for, and it's just going to be an empty list. If it's an empty list, we're going to show a message there that says no results found for blah, 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 whatever you searched for. So that's why we need this as 3 states. So this null value is going to be used as what I call a sentinel value. Okay. The other thing we're going to add is something that will track what the user inputs, because when we search for something and there's no results, we want to show a message that's customized. We're going to show a formatted string that says no results for blah, 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 whatever you entered. All right, so next we're going to have a field that maintains the state for what the user entered. And the reason why we want that is because we, as I said earlier, we want to show a no results found for blah, blah, blah. And that blah, blah, blah is whatever the user entered. And since that is reactive, we want that as a member of our state here. So our state class. So we're going to have a string, and that string is going to be called _input. And the default is just a blank string here. You can ignore this blue squiggly line because we're going to fix that in a later step. Okay. So let's implement our grid view now. So the grid view, there's different types of grid views. There's like GridView.builder that's used for like showing an infinite amount of search results where you don't know what the count of the search results is yet. That's not what we want here, because this is a search screen. When we return the search results, we're going to know how many search results we have. So we're going to use another method here to create a grid view called GridView.count. So GridView.count, and I'm going to paste in the code here first, is going to be in a column. And let me talk about the layout before I paste this in. So when we think about layout, we always have to think about how the data is going to be laid out on the page. We're going to have a grid view, but we're also going to later have a text form field for the search input. And so because we're laying out data from top to bottom here in a column format, for the layout, we're going to use column, right? So let me paste this in and I will go over the results here and talk through it. So in the body, you can replace this with something like this, and I'm gonna talk through that. All right, let me make the text a little bigger. So I have a column here, and it has a number of children. There's going to be 2 main children here. So there's going to be the form text field at the top. We haven't added that yet. That's why I have a empty container here on line 23. And then we have the grid view. And because the results that I just went over can be null, we want to make sure that we don't kind of like try to access that null value. So if that null value exists, that we're going to just have an empty list and just call is not empty. If results has data in it, this won't be a null list, and is not empty will be true. So what this kind of syntax does, results and then the double question marks, means that anything to the left of those question marks, if it is not null, that value is going to be used. If it is null, if results are null, the value to the right of those double question marks are going to be used. So I write about this more in my blog post if you want to read up more on that. So I have a grid view next if the results are not empty. So I'm going to show a grid view.count. So it's going to create a grid view with a finite number of items. You can ignore some of these formatting parameters. I don't want to go into that right now. They are pretty straightforward, and you can read the documentation on that. But the main takeaway I wanted to highlight here was the results. So for my children in my grid view, I'm going to take my results and I'm going to map them to a text field for now. I'm just going to make sure that I'm just showing text. And as you can see on the right, it's like really kind of like small, but you can see it a bit. Those are the 3 names of the 3 search results I have: Adam, Addie, Adre. I just made up some names. So if results are empty, it instead is going to show this, which is a padding widget. And that padding widget will be conditionally rendered, meaning if the results are null, it's going to show blank. That's when our app starts. Like, there's nothing to show here. I don't want to show a message. If our results are not null, I'm going to show a text message saying no results for input. And this input is whatever the user entered. Now, I haven't wired this input field up to the actual text form field. We're going to do that in a minute, but that's how it's going to work. Whatever the user enters, it will be wired up to this input field. And this is an example of theming. So for the theme, the text style for this field, I can just access the text theme I have set up. And what I have done is, for the text theme, I have set up a special text theme of type caption. And we can see that by going to style.dart. And I'm going to paste in now the actual style that we're going to use. So let me, might as well get this done now. Here we go. So I'm going to replace app theme. And I'm going to have, you can copy and paste this in from the blog post or the source code. So you don't have to, I don't encourage typing all of this in. But what it has is two things. One is some text theme for the placeholder text in the form field. You'll see in a minute that there's some placeholder text. Placeholder text is like when the user didn't enter any input. And then you have an app theme. And this is the app theme that's going to be used for the entire app. It has many members. One is for the app bar. One is for the primary color, the font family that we're going to use. And then here we have text theme, and then we have multiple text themes. We have headlines, we have body, caption, and this is the caption I was referring to. So caption is just something that is like kind of like a small text or something ancillary that you want to show that's not really emphasized. So it's going to have like a color, font weight, font size, etc. And the reason why we have an error here is because we're using a custom Google fonts. We're using the rubric font, and here for the main font family, that's not the nav bar, we're going to use the outfit font. And how I searched that is I went to fonts.google.com and I just found the fonts I liked. And as long as it's on that site, you can just type that and in here, and it offers that. That's what the package offers. Now, to install the Google Fonts package, I open my terminal. And I'm going to say Flutter pub add Google Fonts. And it is going to update my pubspec YAML file. And there shouldn't be any more errors after that. So go back to my code. And I'm going to make sure I import this. So I'm going to say import package Google Fonts. And then Google Fonts.dart here. And now there's no error. Okay, so we have our theme, and in our app.dart, you'll see that it's already applied to our material app. So I pass it in with the theme parameter here. Okay, so the style's out of the way. Now we can use whatever theme we want here. So let's reload, and we are going to continue because we have to add our text form field next. So you'll see this in action, this kind of like results message. All right, so let's do that now. I'm going to open search.dart, and up here in container here, right under the top item in the column widget, I'm going to remove this container here, and I'm going to paste in a text form field. And I'm not going to type all this out because there are a lot of properties to customize. And I could have broken this huge thing out to a separate widget, but I'm not going to do that in this video because it's relatively simple, this screen. This is more or less it that we're going to implement for the search screen beyond the private methods that we're going to implement in a few minutes. So what this is a text form field. It just gives you a way for the user to enter text in there. I style it with a body text. And I define this body text in my style file here. You can see body text 1. And I have an onChanged handler. So we need to implement this. So I'm going to implement something that's like a placeholder. So it just doesn't error out right now. And we can implement that in a moment. So at the bottom of the set state package, I'm just going to add on search field changed, and it's just going to be a function here, and the value that gets passed in is whatever the user types. So every time the user types a letter, this function is going to get called, and it is an asynchronous function because soon we're going to call some asynchronous code. And when we do that and we use we're going to use this await keyword, it's going to need this keyword here, as you'll see. So the error is gone, cool. And now I have just some basic decorations. So I have some hint text, which is like the placeholder text that appears when there's nothing typed in. I have hint style. So placeholder text field style comes from my style class. So I'm going to import this style.dart like so we don't have any errors. And I'm going to save this. And now you can see here in the app, it refreshes and I have a basic text form field here. So there, it works fine. Okay. So next, the text and the search results are not styled. So now we're going to style that using a custom widget we'll have to create because we don't want to bloat this file too much. And because this widget we're going to need, because it's going to represent a single search result or a single grid item in the screen here, we're going to just call it tile.dart. So because this widget is not used anywhere else in our app, I'm going to just add that widget to the same directory. If it was a shared widget, I would have kept it in another directory called like shared or components. You can name it whatever you want. And if other screens, if your screen app has multiple screens, it can use that and share that. But because this is only applicable to the search screen, I'm in the search directory. I'm going to create that. So I'm going to call it tile.dart. And it's pretty straightforward. I am going to touch on a few things though on how we do a gradient, color gradients and all that. And because I'm changing so much here, like the formatting and all that, some of the things I'm implementing, they're not going to appear for hot reload. So certain things that I add, like when I apply an app theme or I change the style of something or I change some basic state, sometimes this hot restart or hot reload, it won't do anything. So you're going to have to completely stop the app and restart it to see the actual changes. So we'll do that in a minute. So this tile widget is going to be used for each search result. We're going to pass in a title for it. And notice I kept that name very generic. It's not name or anything because, heck, I might want to use this widget somewhere else in the app later, maybe, if it's going to get built out. And maybe it's something that's reusable. It doesn't necessarily show a username. In the build function here, I have a stack because I'm going to have a background with a color gradient. And above it, that's floating on top of it, is the user's name. So I'm going to have here a linear gradient, and it's going to go from the top right and to the bottom left. And these are my colors for the linear gradient. These are randomly generated colors just to show some variation in the search results. And you don't need to kind of get obsessed about like how this randomized code works. But you can read up on the documentation if you just kind of like click into each field here. It's basically creating a random number here, and then it's going to select that random number, use that random number to access one of the colors from all the primary colors in the colors class here. So the primaries is basically a list of colors. And then this is my user's name. So on top of this stack, in the stack widget, on top of the gradient here, I have a column because text is going to be laid out from top to bottom. So that's why I have this here. It could be a bit overkill. Maybe I don't need column, probably. But later, if I want to add stuff in here, it'll just be easier because I already have that column widget. So I have this main axis alignment end, so that means that the name will be at the very bottom of the tile, and cross axis alignment stretch. So stretch means that it's going to stretch from left to right as much as it can. And then I have my text. I put it to uppercase, just as kind of a styling thing. I want it all in uppercase letters. It's this style of headline 2, and we've defined that in style.dart. Headline 2 is here. It has a certain font size, a font weight, and all of that. And then I have text alignment end. So I want the text to align at the very right side instead of the very left side. So we save that. And now we just have to update this. Instead of text in the GridView item, we're going to say tile. And I'm going to import this. And one trick, and if you're using Visual Studio Code, is you can click this light bulb icon and it'll let you import the library very easily. You can alternatively do command period, and then it'll show you this helpful menu here, and you just enter and it'll import it for you at the top. All right, let's implement a backend. This is part 2 of three parts. So the third part is integrating all of this. I have a sample CSV file that has 100,000 users in it. And I already generated it. I used a online CSV generator. This is the blog post. So you'll have the link to that in the show notes or the blog post here. So you can click the download button here in the blog post, or in the show notes, I'll have the link to the CSV file. So I already downloaded that before I started filming the video here. So next, I'm going to create a Supabase project. So if you haven't done this before, you basically go to Supabase.io, and I'm already signed in here, but it has GitHub authentication. So you just click sign up with GitHub, and it's free for their basic features, which is way more than enough for your projects. And what I did was, first step is I created a organization in Supabase. So I just named it something like test. As you can see here, these are all my projects here that I have currently for my test account. And also I create a project. A project is typically in a full stack application separated by local, staging, and production. So localhost, if it's like a one person project rather, anything that runs locally on my machine, I have the name of my project / localhost or local. And whenever I run something on my computer locally, it will connect to this Supabase project. When I ship my app to friends and family, I will have a separate project for staging. And when I ship that to the app stores, I'm going to have a third separate project in Supabase called production. And it's going to be called same thing, naming convention wise, Super Search - production or prod. So I want to segment my databases for each environment. That way I can play around with things. I don't have to worry about breaking production. And because different versions of the app will require different versions of my backend. And how versions typically relate to backends is when you have different versions of database schema. So because we're using a database where you need to define what schema you're using, schema is basically tables and columns and all of that, what the names of the columns are, what data types they are, that schema will be versioned as well, right? In this test app, there's only one version of the schema. It is just a simple SQL script, and it says, hey, here's the schema. In terms of managing schema, multiple versions of it, multiple versions of the app, I go into this in detail in another course of mine. I'll add in the show notes, but I'm not going to touch on that now. For this example app, all you need to do is have that basic org I talked about. You can name it test. And again, one single project. And again, it's free. And you can call it whatever you want. I called it, let's say, Super Search, right? So after this, we are going to import our schema. And in the code repository for this app, I have the GitHub link on the show notes. I have a link to the script. So you're not going to want to type this out yourself. You're going to want to copy and paste it in. Okay. And so here is the script. I'm going to open up my blog post here. And the script is quite straightforward on a basic level. But there are new concepts here that even if you're familiar with SQL, it might be new to you. Even Postgres, if you're familiar with Postgres, this might be new to you as well. It was to me, okay? Because of the fact we're using something called full text search. And full text search is a Postgres feature which allows users to take a large volume of data and index it in a way where you can run a very fast and efficient kind of wildcard search. So what we're going to do with the schema is, to get this to work, we're going to have a table called names. We could have called them users if we wanted to, but it just has names in there. It has an ID, which is a primary key, and it just auto increments when I insert a name. And I have an F name and L name, first name and last name. They're all text. Next, I have statement here in SQL that says add a column called FTS. That stands for full text search. And there's some mumbo jumbo Postgres syntax here that says basically generate this kind of like vector, and it's going to take the first name concatenated with a space and the last name, and you're going to specify the language it's for and add it to this special vector full text search column, and generate that column with all this data in there. It's going to be especially indexed data so that we can perform a full text search query. You'll see how that works in a moment. Lastly, I'm creating a traditional database index here called name FTS, because I'm creating an index on this field here. Oh, that's a typo. I'll fix that later. Because when we use a database, indexes allow us to look up that data very quickly. So let me take all this, and if you don't really understand what I'm talking about here, if you're not familiar with SQL or whatever, that's fine. You can read up on that. I have a link here in the script to a great article from Supabase about full text search. You can read if you want to. What I'm going to do is going to basically copy this, go into Supabase, and I'm going to go to the SQL editor. And I'm going to go to create a new query here. And I can paste in whatever I want here. And let me fix this names FTS here. And I'm just going to run every statement, all of them at the same time. So whatever I paste in here, it's just going to run. So I'm going to hit the run button at the bottom right here, and it's going to crunch away. And the index already exists. The names table already exists because I already set this up before I filmed, but I just want to show you that how you create this. So we should have the schema here now. If you want to look at the schema in the database, you can go to the left here in the table editor. And on the left, you'll see a list of all the tables. And you click on the names table. We have the names table set up, which is awesome. And I've already imported this data. So this is the example data. It's going to have the ID column, first name, last name. And then this is the FTS column, which is this special full text search column where we can search by this. And I won't go into the internals of the formatting and why it's formatted like that. So we have all the data. Now, when I set up new schema, sometimes I want to play with some queries. I can do that if I go to the SQL editor here, and I can replace this with whatever query I want. In the code repository to this project, there is also a file that has some sample queries you can make. It's a .sql file in the root of the project. All right, so you could do that if you want to. What I would recommend is if you're following along in the video, at the minimum, after we import the data, we're going to do that next. After we do that, we want to make sure that the data is actually there. Does the table exist? If we click on the table, does the data exist? And do you see the data? Okay. So next we're going to import this data. So importing data, now in Supabase, if you want to import some CSV file as data, you can do this basically when you create the table in the UI here. There's two ways to create schema in Supabase. One is via a UI, and that you can click around and it's very visual, and you could say what columns you want. The other way is using a snippet of SQL, which we did. We took that route and we pasted in a SQL script, little snippet, and it creates all that schema for us. The reason why we did it in the latter way is one, you have it versioned in your GitHub repo, and two is that there's a limitation to the Supabase UI that is when you import a CSV file, you can only import it when you first create the table. And because we're creating a more complex table here, we're just going to want to create the schema on our own and have the flexibility to import this data whenever we want. So you can forget that feature if you want to import. I wouldn't recommend importing a CSV file when you create the table. It's messy and it's just not going to work well. And when we visually create a table using the UI, we can't use these special features like adding a full text search type column and all that, at least right now. So what we're going to do in this video is use something called a SQL client, which is a program you install on your computer, and you can either run it with a command line interface or an actual app, right? So typically, like for Windows, Mac, Linux, there are a lot of different options out there. So what I like to do is I use one of two types of SQL clients. One is called Table Plus, which is free, and it's for Mac, Windows, Linux. If I'm using a Mac, I can also use something called Postico, and I have the link to it in the show notes. And that's also a really nice client, but it costs some money if you go beyond the trial. And so I'm, for this demo, going to use Table Plus. And again, why are we using a SQL client? We want to import our CSV file. We need the data in there. I have it here on the screen already, but you're going to need to do this. And if you want to run some queries, it's really useful to kind of get a visual look at the database. So when I download Table Plus, I'm going to create a new connection. I'm not going to do that here because it's out of the scope of the tutorial. But in the blog post, I have directions on how to set this up, because when you set up a connection to a database using a SQL client, and for the people who have done full stack development before, you've probably already done this. I would be very surprised if you have not. But if this is your first time, especially when using Supabase, what I would do is go to your project, make sure it's the right project in Supabase. I would go to Database in the Settings area here. And in the database section, if you scroll down, there's a section called Connection Info. And this has all the important connection info for your app. So it has the URL of the projects you want to use and the host name. You're going to need to supply that. This is my project ID I'm using here. And I have my database name, my port, my user, and the password. When you set up a project in Supabase, remember to write down your password. Because you won't be able to get it back if you don't write that down. You'll have to just remove the database and create it again. So you have all the information you need to set up a connection. So on the screen, I'm going to drag on the screen Table Plus, and it's very small text right now. I can't increase the size, but I connected to my database and I see my table here. It's in the left column here. Again, sorry, it's so small, but next thing you want to do when you import data is that most SQL clients let you import data from a CSV file. I don't know of anyone that doesn't. Visually, it's very easy. You can also do it from a command line. So I'm going to right click on the table name that we created, and I'm going to say import, and then from CSV, and then I'm going to select the CSV file I want to use, and I'm going to select the columns I want to import. So the CSV file is going to have a first name column and a last name column. And in my blog post, I have some more detailed instructions on, how to do that exactly. But it's pretty self-explanatory. And then it's going to import and run. And you can try out a query or two here if you want to make sure the data's there. But again, at the minimum, go to your Supabase UI here, go to your table, make sure the table's there and the data is there before you continue. So that's it. That's how we set up the data for the database. All right, so let's go to part 3 now, integration. So what we're going to do first is add our, let's cover what we're going to do. Add our Supabase Flutter package. And big warning here, there's another package called just Supabase. Don't add that, add Supabase Flutter. So I'm going to say pub Flutter pub add Supabase Flutter. I'm going to open my terminal. And I'm going to run that. It's going to update my pubspec YAML file. And first, we're going to update main.dart. And we're going to instantiate Supabase and set that up. Now, to set up Supabase in your code, you're going to need 2 values. And you're going to get that from the settings here. The two values are the URL to your Supabase project and the anonymous/public key. And you can get those via API. And in the API and settings, you are going to see this in the config section here, the URL. So it's going to be your projectid.supabase.co. Don't worry, this is not private information. This is all public. And also the anonymous pub key here. So that's also public for everyone because we're going to use that for accessing publicly available data. And there's another type of key, a secret key, if you want to do something more secret or private. And then Supabase has a bunch of different like security features if you're needing that. But that's not in the topic of this video here. So I have my URL and my pub key, and that's what I need to get the code set up. So let's go ahead and do that. Let me open my code here, and I'm going to open main.dart. And then go to app. And so I have my app here. Actually, I want to do this in main.dart, sorry. And I'm going to paste in the following because, typing it out is error prone. Before I type this out, one gotcha is you're going to want to make this async because of when we instantiate Supabase, we're gonna use this await keyword. So we're going to make sure we add that. It's going to behave really weirdly or not going to compile or not going to work well if you don't have that. So let's import our Supabase package. I'm going to do command period on a Mac or control period on Windows. I'm going to import that. We have our package added to our pubspec YAML file automatically with our command line that command that we ran. And then I'm going to just copy in the URL part. So I'm going to have something like this. And then the anonymous key I'm going to paste in. I'm going to say copy. And I won't copy it here. Well, I guess I'll copy it here. That's fine. So now in a realistic app, you're never going to hard code this in. This is not a good idea because you're going to build the app for different environments that you have. Remember, we talked about localhost, staging, production. So that usually is done via like some package, like some people pass these values in with an environment variable. That's a topic for another video, such as like flutter.env is a cool package that lets you do that. But anyway, we're going to just paste this in here for now just to get it to work. And it's not the end of the world if you don't keep these super secret. They're publicly used, right? If I were to implement this as a web application or a client-side JavaScript application, these values would be used as well. It's nothing nothing to hide here. So I'm going to hit save. And I'm going to stop the app because I've added this. I've added a new package. Hot reload or hot restart is not going to work. Okay. So before I get all this working, let me just run it to make sure things actually don't crash when I start this up, but I'm going to keep going here as it builds. First thing we're going to do is add our Supabase Flutter package in search screen because we're going to need it when we wire all this up. We're going to remove our hard-coded data because we're going to get this from the backend now. And we are going to implement the onSearchField changed method. And you remember that we have the shell of the method here filled out, and now we can implement it. Now, let's talk about what we want to do in this method. This method gets called, as you remember, whenever the TextFormField value changes, whenever the user types in a letter. So what we want to do is whenever they type a letter, we're going to kick off a new search. That is going to be done this way. So first of all, because I have this state here, I have this field called input. I want to update this because my screen is reactive to that, whatever the user entered. If we want to show this kind of no results for input message, it has to be reactive. So let's implement this now. So what I want to do is update the state in this input state when the value is passed in. So what I'm going to do is I'm going to say set state, And I'm going to say input equals value. And also, if the value is empty, I want to nullify the results field. And remember that the results field should be nullable, because when the results field is null, I want to show this kind of like no results area here on the screen. I don't want to show an empty list of search results. I want to actually show a message. So we have to set this to null. So what I can do is I can say if the value that the user enters is empty, set the results to null right here. Okay, and this is all fine to do in set state. The other thing we want to do is we want to set the state immediately, but we also want to query our database. We want to query our backend. And here, since it's a simple app, we can do that right in the code here. We don't need a special model file or a state management package or whatever. If we wanted to do something more complex like mocking or integration tests with mocking or using a repository pattern or something like that, we would invoke something outside of this file. But if it's just a simple example and we're just showing data on the screen, it's fine to make the actual call here, especially because calling this, using the Supabase library to call your backend is very, very easy and has minimal code. So it makes our screen very clean. But again, when you're building out a more professional app and it's cleaner, you have a more built out app, you typically want to separate your core business logic and whatever is going on in the backend, the internals, things that don't deal with rendering stuff on the UI. You want to keep that separate with the actual widget code that is generating the UI, right? Just to keep it clean. Anyway, so let's implement the results here. So we're going to fetch the results by saying await and then some private function denoted by the underscore called search users. When the results return, we're going to call set state again and paste this in here. Let's just see here. This is a little redundant, sorry. So we're going to call set state again because this await could take a second or something. And while we're waiting, we don't want to kind of wait to set the state. But when we do have the results back, we want to set the state for this. Okay, so let's implement this search users method here. So search users, I'm going to just paste in here and then just talk through it. This is the last bit of code we pretty much have to write. Note that in my kind of like main repository where this code is, I commented the code very heavily with more detail on why I made certain decisions and all that. And in the blog post, I have a lot more detail as to, some of the background on what we're talking about here. All right, so let's talk through this method here. It's going to be called search users. It is private because it's not called from outside this class. So we have this underscore here, and it returns a future because this function that's called is done asynchronously, and it doesn't. We don't know how long it's going to take, so that's why it is a future, and it's a future that returns a list of strings. Each item in the list is a user's name, and it is async because we're using this await keyword. And this name here is the value that it's the value of what we want to search, okay, is what the user entered. So to use the Supabase library here to search, we're going to say Supabase instance, which is a singleton. We're going to access this global instance, and we're going to say client. You can either access something called client or auth. Auth is for doing auth stuff like sign in and sign up and all that. Client is for actually accessing like one of your tables in your database. We're going to select what table we want to select from. We're going to specify that here. The fields we want to access, these are the fields, these are the columns names that we have. And there's a special method here called text search. And this is using the full text search feature. We're going to say what column we want to search against and then the value. So we're going to inject the name here into the string. And there's a special syntax to say this basically means anything that starts with the name, but anything that comes after it is fine. So that's a wildcard search. We're going to want to return a limit of 100 because the user is not going to want to sift through more than even 50 items, and we don't want to return a lot of data. So that's very important. So if it returns an error in the results, we are going to just print an error message and return a blank list. Now, this is not proper error handling. Usually we would actually one way of doing error handling here is to like throw an actual error, and whatever is invoking this function will handle that thrown exception, and it will show something nice on the screen and also send off the exact error message to a remote logging service so that you can monitor it and get an email when it happens, such as rollbar. I like to use rollbar. So this is very trivial error handling here. But if there is no error, what we're going to do, we don't have to deal with JSON, which is nice, but we have to take the form that the data is in that's returned from the Supabase package and convert it into something that we need to use in our UI. So we're going to have a list of names here, and we're going to populate this list. We're going to inject each name that we get. So we're going to iterate over all of these results. So if the data is null, question mark here, we're going to use a blanks array. This is just for safety, but data is going to have something in it right here. It's not going to be just null, but just in case it's null, that's a safety. And for every item in that list, we're going to handle that item. So every item in the list, every item in the result.data member here is going to be a map. And a map is just a list of key value pairs where each key is a column in your database, and you can access it via the column name, and the value is the value. It's of type, here it's dynamic, but it really is a list of maps, right? What it returns. So we can use that. We can say, we can add to our names array the first and last name as a formatted string. So V represents an instance of a map, and we can access each value in the column via just the map key. So F name and L name. We add it to our array and we return it. And that is the implementation for search. So let's try it out now. I'm going to stop my app because I made a lot of changes. I added a package and I implemented this. So let's see if this works now. Okay, so let's see if it actually searches against our Supabase database. I have the app running on the top right here. I'm going to type in like FA or something. And yeah, I have those values there. They're not hard-coded, as you can see. And these users, if you check, they're actually in the database. If I type in something like totally that doesn't exist in the database, it's going to say no results for, and then whatever you typed, right? So this is a cool way to kind of like show off a search feature because it's colorful and it's pretty fast. So because we're using this full text search capability for 100,000 records with this like really basic, not so powerful database, because I'm using the free plan, it's taking about 25 or 50 milliseconds. Now, if I didn't use a full text search, it would have taken about 250 milliseconds. 250 milliseconds is pretty acceptable, but when it starts to get to 500,000 items or 1 million, that's going to get really slow. And for high performance apps, 250 milliseconds is a pretty slow. So you're probably not going to want to, do a normal SQL search, and there's a different way you do that syntactically. But anyway, that's the code. The search works, cool. And yeah, like what we don't have here is our integration tests or unit tests or anything like that. We're also, as I mentioned earlier, we're not doing like .env. We're not configuring the values we're passing into the Supabase package via environment variables or anything like that. So those are some other things. If you want to see those videos, let me know, and I'll create those videos. And if you want to learn anything else, like anything from this tutorial, anything else, just let me know and reach out. So I hope you learned a lot, and thanks a lot for watching.